Now from this section onwards, we'll try to configure some routing protocols over the DMVPN implementations. So the first thing, we'll start up with phase 1 using RIP version 2 in this section. So in my scenario, I got a scenario here as per the diagram. Everything is pre-configured. If you try to see here, the router 1 and router 2, router 3, router 4 are already pre-configured with the DMVPN phase 1 implementations. So which means on the router 1, I'm using multi-point GRE, whereas on the router 2 and the router 3 and the router 4, I'm using normal GRE, classic GRE point-to-point connections. And then on the NHRP side, I'm using dynamic mapping. Now either we can use static mapping or dynamic mapping. So these are the things which are already pre-configured in my scenarios, and we have seen how to configure all these things in our previous sections. Let's go quickly and verify the configurations what I have on the router 1. If I go to router 1, show run interface, tunnel, I have already a tunnel created, and the IP address of the tunnel is 10.0.0.1, and then I'm enabling NHRP on that particular interface, and then the tunnel source and the destination, there's no destination. Instead of that, there is a multi-point GRE configuration. Let's go to the router 2. On the router 2 also I have a configuration. If I give show an interface tunnel 1234, which I created on the router 2, I got an IP address, and then the NHRP is enabled, and there is a mapping to the server, that is a next hop server, and then tunnel source, tunnel destination. Now the same kind of configurations I have on the router 2 as well as on the router 3 and the router 4. Let us quickly verify the same. Now if I give show an interface tunnel TU1234 to show run interface tunnel TU1234. Now I got the same configurations on the router 3 as well as on the router 4. So let's verify on the router 4 as well. Show an interface tunnel 1234. Now the next thing, we'll try to verify the connectivity from the router 1. I should be able to ping to the tunnel IP address on the router 2. I should have a reachability. Now the same thing on the router to the router 3 as well as on the router 4. Now similar way, we have a spoke to spoke reachability. So the DMVPN phase 1 is already pre-configured in my diagram here, and we have seen already how to configure that particular things in more in detail in our previous sections. Now probably in this section, we'll try to focus on implementing RIP version 2 over DMVPN phase 1. So let's try to configure RIP on this particular routers. So I'm going to run router RIP using version 2, and then advertising the WAN interface. In our scenario, the tunnel interface is 10.network, and advertising the LAN interface. Now on the router 1, I got 192.168.1.network here. So let us do the same thing on the router 2 as well. So almost all the commands are same except the LAN interface. I just need to change the LAN interface to 192.168.2.network. And the same thing on the router 3 as well. I need to change to 192.168.3.network, and on the router 4 I need to change the LAN interface to 192.168.4.network. Now I should see the route should be coming up. If not coming, there are some more addition of the commands we need to add. I can see on the router 4, I can see the route is coming from the router 1, and if I go and verify on the router 1, if I give show IP route RIP, I can see on the router 1 I'm able to see the routes coming from the router 2, that is 2.network, 3.network and 4.network from the router 234. Now similar way, let's verify on the router 2 as well. I should see the routes, and similar way on the router 3 as well, I should see the routes. So now there are some few additional commands we may need to configure in some cases. Like in case of RIP, it's really not required. But in case of EHRP or OSPF, there are few additional commands we need to add. As in case of EHRP or OSPF or RIP, they use as multicast addresses to send hello messages in general, right? So in those kind of scenarios, we need to ensure that the NHRP is going to allow that multicast addresses. Now we need to add this command. Either we can say IP NHRP map multicast dynamic for anyone, or we can specifically map the spoke addresses, that multicast address is allowed only for these specific spokes. Now this is something you need to add if you are running any EHRP protocols. Probably that's something not required for RIP, But if you just want to go and add, we can just go and add. So in some cases I have observed it doesn't come up if you don't add that. So what I'm going to do is I'm going to say IP NHRP map multicast dynamic. Now this will ensure that the tunnel interfaces are able to send the multicast addresses, so that in case, because normally the dynamic routing protocols uses multicast addresses to identify each other. So there is one extra configuration we need to add, not required in most cases in RIP, but that's something would really required if you're running EHRP or OSPF protocols. Now the next thing, if you observe here on the router 2, I can see the route which is coming from the router 1, but the router 3 and router 4 routes are not coming. Now if you just observe the diagram here in my scenario, I'm able to see 192.168.1 network, which means this 192.168.1 network is coming here. But the problem here is this 2 network is not coming here, and even the 3 network is not coming on the router 2. Now that is something because of the default split horizon rule, because the default split horizon rule says that an update received on one interface should not be sent back on the same interface. Now here what is happening is the 4 network is advertising the route. As it is a point-to-point connections, the updates are going on this interface, and in order to send back, it has to come back on the same interface and reaches here. Now here there is a split horizon rule says that an update received on one interface, so you are receiving on the same interface, and it is not supposed to send back on the same interface again. So probably if you're implementing some hub and spoke kind of implementations, even the same thing we have seen in the frame relay as well. If you have this kind of implementations, we need to ensure that we disable the split horizon rule on the hub router. So if you want to ensure that your spokes should reach each other, they should see the routes from each other, we need to disable the split horizon rule in our scenario here. So if you want to see the routes, then we just need to go to the interface tunnel 1, 2, 3, 4, the tunnel which I created from router 1 to router 3 to 4. We need to say no IP split horizon, no IP split horizon rule, and then just we need to press enter here. Now once we disable the split horizon rule on the router 1 tunnel interface, now I should see the routes must be coming here. So let me try clearing the clear IP route. So whenever you make any changes, just use clear IP route star command in case of RIP. Now I can see I'm able to see the routes coming up. Now I can see the routes, that is 3 network and 4 network coming from the router 3 and router 4, and the same thing I should see here as well. So whenever you make any changes, use clear IP route asterisk command in case of RIP. Now I can see the routes are coming here. The same thing here as well. So on the router 4 also I should see the routes coming from the other spokes. I can see the routes here. Now there are two major things we need to keep in mind when you are running RIP as a dynamic routing protocol. The first thing is just ensure that we are going to configure some command allowing NHRP to forward your multicast traffic. That is something we can do by using IP NHRP map multicast dynamic command. And the second thing, we need to ensure that we also disable the split horizon rule on that particular hub router. Now these two commands need to be configured only on the hub routers, not really required on any other routers. We don't need to make any changes on the spokes. Now these two changes we need to configure on the hubs in order to ensure that the routes coming from the router 4 should go to router 2.